Every day in school cafeterias across the United States, unopened milk cartons, sealed fruit cups, and packaged snacks are thrown away. This is because of a normalized cycle of waste that has become acceptable. Meanwhile, students face food insecurity across the United States every single day. Seeing that disconnect in our own cafeteria is what inspired us to create RePlate.
Schools waste an estimated 530,000 tons of food each year, and about $1.2 billion from the National School Lunch Program is lost annually as a result. Studies show that up to half of cafeteria food goes uneaten.
A significant portion of the waste includes fully unopened and packaged foods that could be safely recovered. Schools lose money, and perfectly edible foods end up in landfills instead of supporting students who need it. The food insecurity crisis is not a result of a shortage, but rather a system design flaw.
Our primary beneficiaries are students facing food insecurity within schools that already operate food programs. At the same time, our adopters are schools and districts that are losing money to unnecessary waste and struggling to meet sustainability goals. Some schools use shared tables or donation bins, but those systems rely entirely on student participation during short lunch periods. Realistically, students are rushing to finish eating and get to class, so sorting food is rarely a priority as they end up dumping it all in the trash. When recovery depends on reminders and voluntary behavior alone, it becomes inconsistent and unsustainable. We realized that we wanted a solution that truly scaled, and we needed to make it automated instead of depending on changing long-term habits.
RePlate is an AI-powered tray scanner integrated directly into cafeteria tray return stations.
When students return their trays exactly as they already do, an overhead camera scans the tray. If the system detects a fully unopened, approved packaged item, then it automatically diverts it into a sealed, food-safe recovery container. Everything else continues to normal disposal. This removes additional effort for both students and staff while making recovery consistent.
Food safety is our top priority. Our innovation focuses entirely on sealed, shelf-stable cafeteria-issued items with visible expiration dates like applesauce and prepackaged grilled cheese. We are not collecting hot food or partially opened items. Recovered food would be redistributed within same-day service windows and aligned with district food safety policies. By starting with a narrow category of items with a set standard for quality, we reduce risk while proving effectiveness.
The system uses a commercial-grade camera, a computer-trained vision model, and a mechanical sorting mechanism connected to a food-safe container.
Because cafeterias use standardized packaging, the AI only needs to recognize a defined set of approved items rather than every type of food possible. This significantly lowers complexity and improves accuracy of identification. When students return their trays, a camera will use the computer vision to scan their entire tray. If an unopened item is identified by the AI software, the system will redirect it into a sealed, food-safe container, while non-recoverable items are discarded in the trash as usual.
The food that is recoverable will then be redistributed, reducing food waste without disrupting student schedules or adding responsibilities to staff.
We created a layout prototype and presented it to school administrators and cafeteria staff to assess practicality. Their feedback helped us to refine maintenance concerns as well as implementation and feasibility. Importantly, they agreed that automation would be far more realistic than relying on students to change behavior, with over 96% of respondents from our survey agreeing that our solution would be helpful or at least somewhat helpful.
We are designing RePlate to be modular and cost-conscious by using commercially available cameras and off-the-shelf computer components rather than designing custom, expensive hardware.
Our initial prototype is projected to cost about $1,000 to build. As we refine the system and move towards a small batch production, we estimate the per unit cost would decrease to approximately $800. For our pilot phase, funding will come from a combination of community fundraising, sustainability grants, and partnerships with local organizations. Our team has previously raised over $5,000 this past year through student-led initiatives in partnerships with other organizations, demonstrating our ability to mobilize financial support. Long-term, once we validate measurable reductions in waste and overpurchasing, schools will have a financial incentive to invest.
By proving that RePlate helps districts recover value and improve efficiency, adoption becomes an investment rather than an expense.
RePlate reduces edible food waste, supports after-school snack programs, and transforms actionable data into efficiency. By embedding recovery into existing infrastructure, RePlate creates a system that works every single day.
In the first 6 months, we will finalize the AI recognition model and build a functional prototype. Between 6 and 12 months, we plan to pilot in one partner school and measure recovery rates and operational impact, as well as identify any issues that need to be addressed. In year 2, we will refine based on pilot data and begin district-level expansion.
As students, we see this waste daily, which gives us urgency and insight into how cafeterias operate. Our background in robotics and computer science gives us hands-on experience in coding, hardware integration, and sensor systems. Our involvement in school organizations gives us the network to fundraise, pilot, and scale. We understand both the technical side and the social context, giving us the necessary skill set to make RePlate a success.
The food isn't the problem, the system is. With RePlate, food isn't just safe, it transforms waste into impact.